So this is just about types of numbers in the real number system. And the first type of number is called natural numbers. Natural numbers. Anyone know what the natural numbers are? Natural numbers? Those are, yes ma'am.
Positive numbers times 1.
Positive numbers.
Like 1, 2.
Yep,
3.
counting numbers. No, not really. Those are the numbers that go shopping at Whole Foods. They're the natural numbers. It's a joke. The numbers that go shopping at Whole Foods. Okay. Okay, boy. It's a tough crowd here. Tough crowd here. Okay. So another way to say that is like the counting numbers. So that's what you could put down here. Counting numbers. Counting numbers. Right? The next set of numbers is going to be called whole numbers. And the only difference between whole numbers and counting numbers is that you add a 0 to it. Okay? So it starts with 0, 1, 2, 3, 4, dot. You know what dot, dot, dot means, right? Goes on forever and ever and ever. Okay? So those are the whole numbers. Next set, oops. So those are the so you could just say, like down here, write a description of it. Counting plus 0, right? Plus 0. The next set of numbers are called integers. Who can tell me what an integer is? What's an integer? Tia knows. Wait, that's not Tia. Tia's. Is there Tia in here? Yeah, that's you. That's what I thought. You weren't responding. Go ahead, Tia.
Isn't it whole numbers plus like the numbers in between them, like a half or?
No.
Oh wait.
Everest.
Is it like the positive and negative numbers?
Yes. Okay. So it's the positive and negative whole numbers. Okay. So the counting numbers, they would start somewhere down here. Okay. Boom, boom, boom. And you'd go like -4, comma, -3, -2, -1. It does include 0 and 1, 2, 3, dot, 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 dot. A lot of times on tests they ask you, what are all the integers between 6 and 7? Even my pre-calc. Well, maybe with you guys, I'm in charge of the math contests, and we have like 6 math contests a year, as well as something called the AMC math contest once a year, which is kind of a fun thing. So I'll do those in here, but they talk about integers a lot, and no one knows what an integer is. So that's the counting numbers. You could call it like negative and positive whole numbers, right? Positive whole numbers. And I think the next thing, you know this symbol means numbers? Yeah? That symbol means numbers. Okay. The next thing is what Tia was referring to, and that's called the rational numbers. Rational numbers. Let's see if this will let me move this. Will this let me move it? Oh, it will. Okay. Rational numbers are any numbers that, including the numbers above them, that can be expressed as a fraction. Okay? So a rational number can be like 1/2 or 0.333 repeating. Why is that a rational number? Because that is exactly the same as 1/3, right? There's some numbers, we'll talk about irrational numbers. So that's a 0.333. Hi. Who? Sharo. She has a sub, but her room this period is next door, right over there, 204.
Okay.
Okay? Okay? What are some other rational numbers? You could have rational numbers are also whole numbers. So you could have 2 in there. You could have negative 2 in there. You could have 0.16. Can 1/6 be expressed as a fraction? Is that a rational number? Because what is that equal to? It's 1600ths, right? So now, if it went on forever, okay, and it never repeated itself, like your favorite number, do you know what number that is? That goes on forever and never repeats itself? At least to our knowledge. Pi, we'll talk. Then it's irrational, right? So if it can't be expressed as a fraction, then it's irrational. But 0.16, that's rational because that's the same as 16/100. That's an exact number, right? This is an exact number. Even though it's 0.33 repeating, it's still an exact number. Other things like square root of 25 is a rational number because what is the square root of 25? 5, right? And that's an exact answer, right? So any number, mumber, not mumber, number, okay? Any number that can be expressed, that can be written exactly as a fraction. Okay? And the next one, it won't let me scroll down anymore, so I'm going to use one of these boxes up here, is irrational numbers. So the one below it, or at the top, wherever you, I got to figure out how many R's that has. 2 R's, okay? Irrational numbers. Irrational numbers are numbers. Who can tell me what irrational numbers are? Go ahead back there.
They can't be expressed with fractions.
Yeah, they can't be expressed as fractions. They're, so you could write that down here. Cannot be written exactly, be expressed. Expressed, you have better vocabulary. Exactly. Exactly as fractions. Who can give me an example of an irrational number? Go ahead there, Allison. Pi. Does anyone know about any other irrational numbers? Go ahead, Everest. Infinity. I better ask Mr. Beamer about that. I'm not going to write it down because he's getting his master's in math. I better ask him. Okay? And he's working on irrational. I'm not sure if infinity is irrational. Or if it's even, I don't know.
Is it very like a concept?
Yeah, I think infinity might be more like a concept. There is a number E, which you'll see when you get to like algebra 2, E, which is like 2.713. There's a button on your calculator, but when you do logarithms and stuff, actually in this book, they do talk about the E in this book if you're interested, but we don't cover that section until algebra 2. But it's another number. It comes up a lot with exponential decay and growth and stuff like that. It's a really important number in higher math. Anyone else come up with another irrational number? Yes, Ian?
Square root of 2.
Good, okay. Any square root that is not an exact square root is an irrational number. Yes, Madison?
0.68 repeating.
0.68 repeating anything that repeats is irrational. Yes, very good. So, what? Yeah, if it get, so, it's okay. Because 0.68 repeating, anything that goes on forever like that, like 0.68, 0.68, anything that repeats forever, that can't, I don't think that could be expressed exactly as a fraction, okay? So that's irrational. What? But 0.3 repeating is exactly 1/3. And when you get to pre-calc, we actually prove that it's exactly 1/3. But it is exactly, it's kind of a weird concept, but something that repeats and you can't be expressed as a fraction is, and there's lots of numbers like that go on forever, like if it were like 0.11111, is that irrational? You guys know what that is? I think that's 1/9, right? So that's exactly 1/9. If you put that in your calculator, you get 0.1111. So 0.111 is not, but anything that's like one digit repeating is going to be rational. Okay, anything that just kind of has a pattern of repeating is going to be irrational. So it's kind of weird. What's another square root I could throw in there? Give me another square root. Any square root that's irrational. Square root is 6. How about, what about square root of 4/9? Rational or irrational? Rational or irrational? Square root of 4. That's rational because what is that?
4/9.
Yeah, but what's the square root of 4? 2, and what's the square root of 9? 3. So that's exactly 2/3, right? So this is not irrational. This would be rational, right? So this would go over in this box over here, as would 0.111. Let's put that in there because that's a good 0.1111. Okay, easy enough. Okay. So now we're gonna flip this sheet over that you have there, and you guys know how to do Venn diagrams. So you are gonna try to fill out this Venn diagram on your own. So you're going to look at this thing, okay? And where is that? I have to get it. I could find it on my Schoology. No. So this is where I look up. No. Up. Yes. What's that? What if I went close this? Let me see if I can figure out how to do this and still be in Schoology. I don't know. Schoology, I'm going to bring up this. Do I have to log in again? I don't know. Algebra Advanced. First semester, chapter 1. So now you guys are going to try to, this is the real number system. So you know the way a Venn diagram works? So anything that is in here is also included in here, right? Anything that is in here. So this big area outside, okay? Oh, come on. Sometimes don't change. There we go, okay? So this big area out here, this is real. All real numbers are all the way, it's like the ocean out here, okay? That's like your ocean. What's in this teeniest box right here? That's natural numbers go here, okay? And you can like put what the natural numbers are. And go ahead, why don't you guys fill in that chart and see how it comes out, okay? Do it in pencil in case you mess up. Oh, that's what I was trying to say. Let's go fast. What goes here? What goes here? Whole. Okay. What goes here? Integers. Integers. What goes here?
Rational numbers.
Rational numbers go here, okay? What goes here? Irrational, okay? So, if something is a natural number, is it a rational number? If something is a natural number, is it a rational number? Yes. If something is a rational number, is it a natural number? Not necessarily, right? If something is an integer, is it irrational? No. Okay, so integers can't be irrational. If something is irrational, can it be, is it a real number? Are all irrational numbers real numbers? Are all, yes, because they're in the ocean of real numbers. See the ocean of real numbers out here, right? So yes would be the answer to that. And you could put some numbers in there to indicate. So this is a subset of this, which is a subset of this, which we're going to talk a minute about sets and subsets. Okay. What else? What if a number is not a real number? What kind of number is it? You know that already? Maybe you need to go to the higher class. Did you ever take Algebra 1? Yeah. You guys have heard of imaginary numbers? Yeah. I's? We're not going to. Well, we talk about it a little bit later on in the semester. Okay? Second semester when we're doing square roots of negative square roots and stuff like that. Okay, so moving on, I got something else for you. I'm going to pause for a second while I fuddle around. It's kind of obscure concept. It's in your book, okay? And so I do want to talk about that. This is called roster notation for a set of numbers, okay? So you might want to take some notes on this. It's just a few minutes, okay, on this. So roster notation is just a way to list everything in a set of numbers, okay? So this is called roster notation. So what this, and each one of these things is called an, here we go. How did I get to that? No. There, now is it going to let me write on there? Now it's going to let me write on there. Don't ask me like that. Okay, so this is called, these are called elements. Those are called elements in the set. Okay? And these brackets just means like everything in there is included in this set of numbers. So that's the set of, it's not all natural numbers. That might be, you might write that as the first 5 natural numbers, right? That's one way you could write it. Okay? Moving on to the next thing. Okay, can I go on? Easy enough? Okay, I could write that same concept in what is called, what they call set builder notation. Okay? So X, so they say, and I don't know why they say between. They should really say including 1 and X is a whole number between 1 and 5, but between 1 and 5, that would only be 2, 3, and 4, right? So what they should really say, put this word between 1 and 5 inclusive. Inclusive means that it includes the 1 and 5, right? So this would be another way to write that previous set. So if I were to, so this is called set builder notation. So this is all X, so this is said all X values for which X is a whole number between 1 and 5, including the ends, okay? So that's the same, this is this, we're talking about the same set of numbers as I have, what's going to happen if I do this? The same set of numbers as this, okay? So that's roster notation. This is set builder notation. And here's 3 different examples of roster notation and set builder notation of the same sets of numbers. So 1, 2, 3, 4, x is a whole number between 1 and 5. I would say inclusive, okay? Including the endpoints, because between implies that 1 and 5 are not part of the numbers. 2, 4, 6, 8, 10, 12, 14, 16. X is an even number between 1 and 17. That makes sense, right? Because all of these numbers are between 1 and 17. Roster, so this is set builder, set builder, and this is roster up here, okay? And this is roster, and this is set builder down here, okay? There's not a lot on it, on their homework on this stuff, but it's just a concept. X is a multiple of 6 between 5 and 37. Here's all the multiples of 6 between 5 and 37. Notice that something like this, if I did like this, 1, 2, 3, 4, dot, 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 that's not the same as this, right? That means all the natural numbers, right? Going on forever and ever. This means just those 5 natural numbers. Yes, ma'am?
In set builder notation, aren't there like symbols that you could use instead of words?
In set builder notation, aren't there symbols? You mean like this? Yeah, this one would be hard to do with symbols. This one would be easy to use with symbols. Like you could write this one as x is greater than or less than or equal to 5. Is that what you mean?
Yeah.
Less than or equal to 5 and greater than or equal to 1. Right? You could also do, but yeah, you could do it like that. Or you could write it like this. Have you seen this before? 1, 5? Have you seen that? Kind of we'll get more into that when we're doing the inequalities and stuff. So this means 1 and 5, including the endpoints. This means 1 and 5. But this is all the numbers between them. And anyway, so this means all of the numbers between 1 and 5. So this would include all the rational and irrational and all that. So in this case, not really, right? Because it's only discrete values that are in there. So don't worry a whole lot about that, but it is in the book just so that you see it, okay? And then the next thing I'm going to talk about, and the last thing for today, is sets, okay? So sets of numbers. We just looked at some sets of numbers, but I can have a set of anything, okay? And so we could say something like set A is equal to 3, 5, 8, 14, I don't know, negative 12, and 57. I'm just making up a set, okay? So this, just some symbols and stuff. This means E. This means is an element of. Is an element. In other words, it's in this set. So you can say that 8 is an element of set A. You understand that? Okay? This says that 8 is in this set A. It's like a kind of a curvy E with a slash in it. How about 14? No, and how about 12? Positive 12. Is 12 in that set? So you would say that 12, this symbol means, is not an element of A. Okay, so if you see something like an E with a slash through it, that means is not an element of. Okay? And then they have another symbol for sets where subset. So this means, if you see this curvy thing with a line under it like this, that means subset. 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 Set. Subset. Is a subset of. Okay? So if I have a set like B, okay, and I put that set, and I said my set B is going to be 3, 5, 57, okay? Is B a subset of A? Are all the elements in B? Subset means that all the elements in this set are included in this set. Are all the elements in this set in this set? Yes. Okay? So you would say that B is a subset of A. Okay? Just like that. You could say that positive integers are, or I don't want to use the words, I want to use the symbol, okay? Positive integers are a subset of what? What type of numbers are positive integers a subset of? What square are they inside on your sheet? Positive integers. So that would be the whole numbers, right? So positive integers would be the whole numbers. So
Be irrational because possible numbers are irrational.
So they would be inside the rationals. They're a subset of rationals, right? They're also a subset of all integers, right? Because they're in, and so on and so forth. Okay? So that's pretty much, I think that's everything I want to talk to you about. Yes, element, set, and so on and so forth. Is, just looking at this, is A a subset of B? Is A a subset of B? No. So if you had this, you would say A is not a subset of B, right? So, right, A is not, everything in A is not in B, right? Okay, and I think that's it for today, for as far as me